Okay, up next we're going to make predictions. So go ahead and put in a new, I guess, make predictions header. And before making the predictions, we're going to want to make a change. So here's the deal. Everything's really fine, but X and Y, X is actually a data frame. And it works fine, but we actually, for predictions, it can run into problems due to column labeling and things that you don't want to deal with. So the better approach is the following. Go ahead and import numpy as NP, stands for numerical Python. Now we're going to redefine X as the numpy array of X and Y as the numpy array of Y. Okay, and what this is going to allow us to do is going to allow for more ease of like the format of making predictions. It's not going to worry about column headers and stuff like that. And then go ahead and like save it and load it. And then the final model shouldn't change because it's just like the kind of the changing of the input. But now we should be able to do a better job of making a prediction. So what are we going to predict? Well, let's just pick a random row. Okay, so let's try df.iloc, say the 200th row. Okay, all columns. And then what we see is, we see the input for this data. We can see it's like the 7th month, so it's the summer, and there's 4,332 rentals on this day. All right, so let's now try to make a prediction using this. I'm pausing. I'm not sure, does x.iloc work? I think iloc is unique for data frames. I think for the 200th row, you should just be able to put in like a, like a 200 like this. Let's check this. And you can see it matches numerically what's above. It doesn't have the Y because that's what we're trying to predict. And if you just check a couple of the rows, like 201, it's clear. Okay, so you could call this like in effect as like the new data. Okay. And then what we want to do is we're going to try to do a final model. There it is if you want it. Dot predict on the new data. Now sometimes there might be something off with the dimensionality. Yes, see it says it must be two-dimensional. So generally speaking, I think the way around it is to add in brackets. And you could do it, I think you want to do it maybe here. Let's try it there. And yeah, there we have it. So you can see, wow, that's a really good prediction. You can see that the prediction was 4,319, but the reality was 4,332. My goodness. Only 13 off, right? Remember that the expected error was about 500. So we're expecting something around like, 3,800 to 4,800 there. Okay, so that's great. And in effect, by the way, you can certainly put in these numbers. So like you could say, well, it takes a little time, but just to show you, because the reality is you're going to have some kind of new data and you want to be able to make predictions from it. And so if I just, here, I'll just type in the numbers that I see. So let's just keep the same instant for whatever reason, same season, same year, same month. If these have to be floats, we'll find out because I'm putting in integers. I'm on the holiday, weekday. I'm going to change the temperature. Working day, weather is it? But now let's change the temperature. Let's say it's much colder, like 0.5 and 0.47 or something. I don't really know how cold that is. Let's say it's windier too, right? 0.19. And we want to see now, like, what will the predictions be? Okay, so just put in final model, dot predict, new data, feature names mismatch. Yeah, this can happen. I may not have counted correctly. Let's check. Oh, I left off this count. Wait, no, that's the df. We don't want that. But let's check. Do I have 1, 2, 3? Why am I counting, right? Like we can use, let's try this. X.shape. You can see it should have 12 values, 1, 2, and I can instead of counting, I can use Python code length of new data. Oh, one that doesn't count the number of elements. Let's check it here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I left one off somewhere. Oh, it's humidity. We'll leave the same humidity. Okay, try it again. And you can see the prediction changed. It actually gave more rentals, so maybe it was like, they think it's like too hot on that day or something. That's the disadvantage of having the normalized temperatures, which you can definitely go back to the original data and fix and make an adjustment there. Just for the fun of it, let's see what happens if I say, well, it's much hotter. Yeah, too hot, less rentals. So that's kind of cool. You can see some of the changes based on changing some of the values. Okay. Okay, so that's basically how you make predictions using your final model.